Intrapulmonary pressure is what? 760. In the respiratory tract, it is what? 0. So what happens to the intrapulmonary pressure? It will do what? It will decrease. It will decrease. Decrease to what? It will decrease to 0. What happens to the intrapulmonary pressure? What is intrapulmonary pressure? The pressure that is inside the what? Lungs. So as the lung volume expands, what do you think would happen to intrapulmonary pressure? As lung volume is expanding, what do you think will happen to intrapulmonary pressure? The volume, the pressure in the lungs. It will reduce. Volume is inversely proportional to pressure. So while the lung volume is expanding during inspiration, the intrapulmonary pressure, which was initially 0 millimeters of mercury, decreases to -1 and sometimes -2 millimeters of what? Mercury. These are the pressure and volume changes we are talking about. And if you understand this, you will clearly understand the mechanism of breathing. Which other pressure do we have? What? Atmospheric pressure. Let's take other pressures. What happens to transthoracic pressure? What happens to transthoracic pressure? During inspiration. What is the value for transthoracic pressure? -4. -4. Okay. Would that pressure increase or decrease during inspiration? We are looking at inspiration. It will decrease. So the transthoracic pressure that is initially -4 will decrease further. It becomes more negative because the lung volume is expanding and air is flowing into the lungs. That pressure decreases, or it moves from -4 millimeters of mercury to -5 and sometimes -6 millimeters of mercury. Now, all of these changes in the lung volume and the respiratory pressures causes air to rush into the lungs. So what we have here is that when you are taking in air from the atmosphere, muscles contract. Thoracic wall moves upwards and what? Outwards. Respiratory volume does what? Increases. The lung volumes are expanding. And then the lung pressures are doing what? Decreasing. It is by this physiological mechanism that human beings are able to take in air from the atmosphere into the lungs. If we want to relate this to expiration, I believe you'll be able to describe what is going on in the respiratory tract during expiration. If we want to go by what is happening inside the respiratory tract during inspiration. Yes. Can somebody tell us the changes, volume and pressure changes that goes on in the respiratory tract during expiration? What's your name? Huh? Olive. Olive branch. Olive oil. Okay. Olive, tell us what happens, the volume and pressure changes in the respiratory tract during expiration. Yes? You don't know. Olive doesn't know. Where are the pharmacy students? They are not even medicine students. Precious. Where is Precious? She is absent. Where's my attendance? Please, pass attendance. So I will call names one by one. Precious is not in class. Huh? Huh? Not in class. She's absent. Good. Where's the assistant course in medicine? What's your name? Huh? What? Virtue. People have some fine names. So, are you a vicious woman? You don't look it. Don't buy me. You're a vicious woman. Okay. Tell us, what do you think happens to the pressures and volumes during expiration? Yes?
My guess is that
your guess. You are guessing in medicine. Maybe you're a medical student. So when a patient comes to your hospital, you begin to do tumbo. You begin to guess. You don't guess in medicine. You don't do that. In fact, if you don't know now, if you're in medicine and surgery, you should have an idea about everything. And do not appear before any external examiner and say this thing that you just said. You will fail. You guess. No. Guessing is not allowed in medicine. So tell us what you know during expiration. Hey, Virtue, you have killed me. She says she doesn't even know anything. A doctor to be? No. This one is even worse. It's even better you guess than you go and say you don't know anything. This one is worse than what you just did now. You didn't hear when I said a medical student or medical doctor must have an idea of everything. You don't know. Because you will see cases from the respiratory system or cells and organs. You will see cases from GIT, cases from blood. Visually, all the cells, tissues, and organs making up the human body. And when you graduate to become a general practitioner, so you should have an idea of everything. Okay. Your name? Huh? Kenechuku. Rachel. Aya, tell us.
The thoracic cavity also decrease. When there is decrease in that thoracic cavity, pleural pressure increases.
Okay. Okay. Rachel. Fantastic. This is the only student that has just made a beautiful attempt. Did you hear what she said? She said during expiration, the muscles will relax. Thoracic cavity moves what? Decreases downwards. Thoracic cavity moves downwards. The volume does what? Increases. Decreases. Because air is going out of the lungs. So the lung volume decreases. The pressure does what? Increases. Look. Go back to Boyle's law. The volume is inversely proportional to what? Pressure. So as the lung volume is decreasing, because air is flowing out from the lungs into the external environment, that means that the pressure will do what? Will do what? Increase. So the intrapleural pressure will do what? Increase, right? During expiration. What is the value for intrapleural pressure? -4 millimeters of mercury, right? So during expiration, because the lung volume decreases, that is, air is flowing out of the lungs to the environment. The intrapleural pressure, which was initially -4 millimeters of mercury, increases, moving from -4 to -3 millimeters of mercury and sometimes -2 millimeters of mercury. Is that an increase or a decrease? So you find out that this intrapleural pressure is becoming less negative. From -4 to -3 and then to -2 millimeters of mercury. How about the pulmonary pressure or the alveolar pressure? What happens to the alveolar pressure? Yes. The alveolar pressure is what? Moves greater than the atmospheric pressure. What is the value for the pulmonary pressure? 0 millimeters of mercury. So during expiration, what you find out is that as the lung volume decreases, the pulmonary pressure or the alveolar pressure, which is initially 0 millimeters of mercury, does what? Increases. So it moves from 0 to +1 and sometimes +2 millimeters of what? Mercury. How about other pressures? Transrespiratory pressure. What happens to transrespiratory pressure? Okay, it doesn't change. No changes. Okay. So, that is that. So, if you are able to understand the pressure and volume changes during each respiratory cycle, then you can beat your chest and say you can comfortably describe the mechanism of breathing in human beings. So you go home and look at that. I've already discussed all of these things, these mechanisms on the materials that you have, explaining the volume and pressure changes during respiratory cycle. So, we can now start our lecture for today. We can now start our lecture for today. No noise. We were just rounding up last week's lecture. Our topic for today is gas transport. Our topic for today is what? Gas transport. Are you tired?
Yes.
How can you be tired in medical school? How can you be tired? Are you hungry? I know that this school gives their students breakfast every morning. In this school, I know that for a fact. So you can't be telling me you're hungry. So our lecture for today is gas transport. Under gas transport, we want to look at how oxygen is transported. Like I said, from the external environment to the lungs, and then from the lungs to the blood, and then from the blood to the tissues. And then we also want to look at how carbon dioxide moves from the tissues to the blood, and from the blood to the lungs, and from the lungs to the external environment. So the diagram you have there shows you. You don't have a diagram? Look at this smart board. The diagram shows you how oxygen moves from the environment to the lungs, to the blood, and then to the tissues. And how carbon dioxide moves from tissues to blood to the lungs to the external environment. Okay? So, one key thing to note is that the same blood that transports oxygen to the tissues also transports carbon dioxide out of the tissues. So in gas transport, we'll first look at what is called oxygen transport. Oxygen transport. That is transportation of oxygen. And when we are done with oxygen transport, we'll now have to look at transportation of what? Carbon dioxide. So I said that gas transport is defined as the physiological mechanism of how oxygen is transported from the external environment to the lungs, and then from the lungs to the blood, and from the blood to the what? Tissues. Are you catching it?
No.
Am I too slow? Fast. Okay. Gas transport refers to the mechanism of how oxygen is transported from